Good morning, everyone, and welcome to another session from Paloma and our friends at the Cross-Chain Coalition, and as well our awesome friends at Connext. Today, my name is Tarek Lewis, and you may know me as founder of Volume and Volume.finance. We launch multiple projects such as the Cross-Chain Coalition, Callisto Finance, and of course, Paloma. And we're hosting this Twitter Spaces on Paloma, which is our cross-chain messenger development system and blockchain for developers looking to take full advantage of the entire cross-chain ecosystem. Our belief is that you're not going to be a blockchain engineer in the next few years, you're going to be a cross-chain engineer. And Paloma is very, very pleased today to have the opportunity to host some of the brightest minds in cross-chain engineering. This is the team at Connext. And with me today is Arjun. I think, Arjun, are you here? Can you hear me?
Yep. Hey, thanks, Tarek.
Rock and roll. And we're here with, of course, our community from Paloma. We have about approximately 3,000 validators who've joined Paloma to learn about cross-chain development. And we're bringing on hundreds of engineers. We have the cross-chain coalition is here as well with the community of, I think, maybe 2,000 cross-chain professionals. We want to give this as much reach as possible. And of course, we have the Volume Finance community as well as those from the Cosmos, etc. So this is exciting. This is a great title today, Bridge Security 101. Why secure bridges matter. And to our friends at Harmony, we hear you, and we know that we hope and wish the best at this time. But it seems like every day something is happening, something in the security aspect of cross-chain communications and bridges that keeps waking us up and bringing us out. And so this is maybe one of our most important Twitter spaces. It will be recorded. It will be transcripted, and we will rebroadcast. We wish to share it with everyone because we think this is important. I think no more time now than today, we need to talk about bridge security. But first, before we jump into the details, Arjun, we'd love to get an introduction to yourself and also about Connext and the team. You guys have deep expertise in this topic. So would you be okay to kick us off and tell us, who are you? How did you get into this space? And how did Connext essentially arrive as the leader in this topic about bridging security?
Yeah, absolutely. So I'm Arjun. I'm one of the founders of Connext and project lead. I first joined the space in 2016, just out of interest because I was kind of interested in public goods at the time, and particularly the idea of building non-sovereign, non-corporate public goods. So things like the internet, which are globally accessible infrastructure that really just have the capacity to take the world on a widespread scale, but aren't necessarily controlled by any specific company or government. Naturally, this led me pretty quickly to Ethereum because it was a core part of the Ethereum vision at the time, and I really was pretty heavily convinced right away that that blockchains and the kind of Ethereum-based vision of a decentralized internet, a decentralized kind of ecosystem of applications and public public infrastructure that can remain resilient to centralized control over a long period of time was really the right way to solve this problem. And so early on, I started building infrastructure for the space. And then in 2017, I and my co-founders founded Connext. And the mission of Connext was fairly simple. We all had the shared belief in public goods and in this space. And the core goal was simply, let's figure out a way to scale this technology and bring it to the next 1 billion users. Initially, we actually thought that this would, we realized this was a much harder problem than we had anticipated because unlike with traditional applications, this was not an adoption problem, it was also a technology problem. So we pretty quickly ended up getting sucked into scalability research. We were one of the first teams researching L2s on Ethereum. We actually built the first general purpose kind of usable by anybody L2 on Ethereum that was actually a true secure L2, which is a payment channel hub and spoke network in partnership with SpankChain. And then we started collaborating really closely with the teams that ended up going on to build rollups. It was about this time that we realized that there was a piece missing from the puzzle. We'd been researching L2s for a very long time, and the world was moving towards kind of these EVM compatible chain-like environments that users would move funds onto, move their applications onto, and then operate there at lower cost and higher speed. But it was really unclear as to like which of these solutions was the right one, and more importantly, it seemed very, very unlikely that we would actually end up with a single in a world where there was just like a single L2 that everybody was building on top of. And that created this really interesting problem, which was what happens if you have multiple L2s? And objectively, that actually is the better solution for decentralization, because you remove the kind of centralizing effects of having to run a bunch of layer 2 infrastructure of one specific rollup rather than a heterogeneous mix of them. And what we realized was that the same kind of like user experience adoption problem that we'd been thinking about for a very long time around scalability was now going to be applied to interoperability. So how do we allow users to use all of this heterogeneous mix of chains and L2s that they were moving onto, in a way where they don't necessarily need to know the intricate details of every single system that they're interacting with. And perhaps even more importantly, how do we empower developers to build applications that are that span multiple chains or L2s? You touched on this earlier, that developers you really believe that developers are going to be cross-chain, not blockchain developers in the future. And we have a strong conviction around that as well. We just think that like it's actually a pretty simple change to make that happen. It's just that similar to when you build web applications and you have asynchrony, because you're interacting with resources that exist all over the internet. Developers will have to have the same kind of thought process when they're building a blockchain application. Well, they'll be deploying their contracts on one chain, but then interacting asynchronously with contracts and data running on other chains.
Yeah.
That's generally what has brought us here. And over the course of the last 5 years that we've been working on this, just because we've been so heavily involved in like the L2 research side of things, in figuring out how to do this as trust minimized of a way as possible, that's also exposed us a lot to the security issues and the kind of security questions around bridging.
Excellent. I think one of the things, as you have seen some of these security issues, and I'm here, I spent a lot of time reading, on the Z Prime Capital post, "The Bridges Are Dead, Long Live the Bridges." It's a great blog post talking about, the different types of bridges, bridges that are heterogeneous versus homogeneous. What is your, and we can consider Paloma falling into the heterogeneous grouping with Axel and others, and so many others coming, with the change and the Terra vacuum taking up the space. Where does Connext sort of feel that developers, cross-chain developers, really should be focusing? How do they say, "Hey, I landed up on Axelar. I didn't choose to be in the Axelar world. I'm here. What do I do next to make sure that I'm building secure apps that take advantage of these communications, whether I'm on IBC or I'm on Axelar or I'm on Wormhole?" Because I think we're getting from developers a lot of like, "Hey, I don't want to be the next Harmony. I don't want to be part of the next Harmony story or the next, bridge hack story." What would you say they need to think about, and what steps do they need to take to become smart about how to sort of navigate this space?
Yeah, absolutely. And it's an absolutely valid concern, because the risk reward ratio for bridges is just so much higher than for an underlying chain. Like you can actually attack bridges. You can 51% attack bridges,
Right.
And use that to steal funds. You can't actually do that on a chain. If you 51% attack a chain, you can create a fork, but no user funds are actually lost. The minority fork can then just continue chugging along. You can kind of de facto the attack ends up just being erased out of existence. But that's not true with a bridge. A bridge ends up having, because it's a mechanism for kind of like porting state between chains, you end up having these really, really weird consequences of the system that don't really exist outside of like the bridge space particularly. And one of the key aspects of that is that the security models of all of these things are actually pretty wildly different. And in general, like even though we've historically been comfortable with the idea of like, oh well, this is a chain that has XYZ number of validators, and that means like it's secure, and that means we can put up to a certain amount of value on it. The reality is that security model is not good enough for bridges. And that's I think where developers are going to like run into problems, is that you have a lot of these like big bridge ecosystems like Wormhole, Axelar, Layer Zero, et cetera, that are heavily branding, that are heavily marketing. The problem is that in effect, most of the security models of all of these things are actually quite similar in that they're just multi-sigs of some form, right? Like I think Axelar has the best model in
Absolutely.
that it's
Yeah.
a permissionless multi-sig, but that's about as good as you can get that. Um, and I think that's one of the places that developers may end up in a tricky situation if they're not careful, because like, you can definitely abstract away the user experience so that a developer is interacting with IBC the same way that they're interacting with Wormhole. But you know, there is a reason. I mean, Wormhole got hacked because of an implementation bug, but like the security model failure there, the underlying security model failure still exists, right? Which is that a very small set of people can actually rug all of the funds. Um, and I don't, to be honest, I don't see how that changes without just much better broad spectrum education about this topic to developers to make sure that they are, because it seems like at this point they are conscientious consumers. They don't want to be the people that get hacked, but it's just that there isn't enough education out there to begin with.
Got it. No, agreed. And I think looking at everything's a big multi-sig model. The question is, what comes after the multi-sig in the Connext view? What is your view that, because even with IBC, and cross-chain passing, there's still some trust. So if we say, listen, the multi-sig is not good enough, what is your view and what's next? What should be good? What should be better, or how do we, get
Yep.
past the grid multisig?
Yep. So last year I wrote a blog post called the Interoperability Trial, which tries to go into like the trade-off space in the design of bridges, and in the design of secure bridges in particular. And basically the core thesis is that like, as with scalability, as with any kind of like decentralized system, it's never actually possible to get all of your desired properties in a single simple monolithic system. And that's just because of the way, it's just because distributed system sucks. Like it's a field that is really difficult to build in, really difficult to do research around. And in the specific case of bridging, those properties that you fail to encapsulate all of are that the system is simultaneously trust minimized. It is generalizable, which means that it can pass around arbitrary data. It is extensible, which means you can actually bring it, you can copy paste the same system onto a bunch of different chains very easily. So there's like low implementation complexity, there's low implementation risk, and you're able to scale it to different chains very quickly. So that's kind of the trilemma aspect. And then over the course of the last like year, we've actually added another property, which is that it is fast. That you don't have like additional latency. And now when you look at all of the different types of bridges that are out there, you can see exactly which ones trade off what, and they fit neatly into this model. So for example, systems that are trust minimized and extensible, but aren't generalizable, are atomic swaps. They've been around for ages. They're quite trustless. It's very easy to deploy them on any chain that supports any kind of smart contracting. But of course, like you can't use them to do arbitrary data passing. Multi-sigs also take a similar prong of this, where it's like, they're generalizable, they're extensible, they're generally fast, but of course, they're not as trust minimized. They add these trust assumptions. Now, the last two are really like the ones that are quite interesting. The first, as we've already touched on, is IBC. IBC takes the kind of third prong of the interoperability trilemma, at least the original one, which is it is a trust minimized system for fully generalized message passing. It actually offers the theoretical best security that you can get, but it's not very extensible. So like IBC style light client validation bridges. Now, just as a kind of like a nitpick there, IBC itself is not actually the bridge. It's just like the framework within which you can plug in security models. But
Right.
generally speaking, the idea is that you have like light client validation happening in these systems. And for that to work, you actually have very significant restrictions on what kind of consensus algorithms you can work with or what kinds of systems you can work with. So for example, IBC works within the Cosmos ecosystem because Tendermint chains are specifically, actually Tendermint itself is specifically designed to be validated in this way. That was the whole thesis of Cosmos. On the other hand, Ethereum and a bunch of other chains that were created at the time went through this really, really annoying phase where people just believed that you need to make every single consensus mechanism at the time very memory intensive to develop basic resistance. Now this didn't actually happen. People still built Ethereum ASICs, so it actually did nothing at all. But because of its memory hardness, ETH POW is actually not. It's not really economically feasible to build a light client for ETH POW. It costs like millions and millions of gas to validate a single message. So I think that's kind of where you run into a little bit of the complexity around this, where it's like, well, we know what the objectively best solution is. It's not actually easy to develop and deploy it everywhere. And that brings us to the last kind of model. And I think that this is really the one that offers the best set of trade-offs that for the space, because it really just like, it mitigates this big security hole question. But of course, it's the newest model. And so people are still trying to get their hands around it and understand it. And that model is optimistic bridges. So this was first pioneered by a project named Nomad, who Connext is really, really closely partnered with. And what optimistic bridges do is that they use a model that is quite similar to an optimistic rollup, where you just post data optimistically across chains, and then you have a certain amount of window, a time latency of 30 minutes within which anyone in the network can basically dispute the data that was posted across chains and slash the person that actually made that update. Obviously the trade-off here is that you have a 30-minute latency. So there's still no free lunch, but I think that generally speaking, what I've seen is that like this model offers the best trade-off between, this is a reasonable amount of time taken to get a message across chains, especially if it needs to be secure, like I'm minting a token, a large amount of tokens or something like that. And it's also offers a very, very reasonable amount of security, as in, the wormhole hack would not have been possible in an optimistic bridge. The Ronin hack would not have been possible in optimistic bridge. The Harmony hack would not have been possible in optimistic bridge. And the reason for this is that like the core thesis behind an optimistic bridge is not, permission, which is, it's not like you get access to all of the keys and now you can attack the system. It's revocation. So you basically would need to figure out everyone who is watching the chain all over the world and turn off their software, which obviously is quite difficult to do, in order to stop anyone from blocking your attack on the bridge. So yeah, that's generally the way that we've been kind of thinking about it, is that like people are beginning to realize that multi-sig bridges have these problems. I've heard of several bridge operators, bridge projects that are multi-sigs that are now moving towards becoming optimistic bridges because they've just realized it is the better model objectively. But of course, it's a harder model to build, and it's a relatively newer kind of piece of the interop puzzle as well.
And so just to sort of orient folks who may not be familiar with the optimistic model, really the optimistic model came out of the Ethereum L2 research. Yep. Would it be correct to say that? Maybe let's talk a little bit, to sort of orient folks who are like, whoa, optimistic. Oh, I know optimism. I know arbitrum. Okay, what are these things? Could you give us a little sort of background into, here's what is an optimistic, when we say optimistic, what are the roots of, the Ethereum research that came into optimistic, L2 communications?
Yeah, absolutely. So there's the initial ideas for this type of model or this type of security mechanism have been around for a very long time. So when we say there is an optimistic model for X, what we mean is that system is using fraud proofs instead of validity proofs. Validity proofs are things like, basically validity proofs are like how zero knowledge rollups work, or how IBC works, which is you take some data and you prove the validity of that data using some mechanism, usually involving cryptography, to be able to know at the time of proving that this data is valid. And then you post it to chain, and you could post the proof alongside it so that everyone can see, hey, this is actually valid. A fraud proof works slightly differently. So fraud proofs first were proposed as a way to build Bitcoin SPV clients, as a mechanism to say, well, okay, here's a simple payment verifier for Bitcoin that doesn't need to validate Bitcoin's POW model at all. All it does is just uses a really, really simple method to count the transactions that have been made. And then if there's something that's wrong, or if you believe that that client was counting incorrectly, it is possible to prove that the client, that, like the like client did that. And because it's possible to prove that the like client did that, you can slash them for it. You can basically like penalize them using, like by removing funds that they have put up as an insurance bond. This model was extended in the ETH L2 research paradigm. So fraud proofs became a much more interesting kind of model for expressive blockchains as a security model for a lot of this core infrastructure. And the way that most people know of it right now is in optimistic rollups. So like with an optimistic rollup, you have transactions that are posted to this thing, which is effectively a proof of authority chain, right? It's basically just a server that is pretending to be an Ethereum-like environment. But that's fine, because all that server is doing is taking bundles of those transactions and proofs and posting them to Ethereum, or at least bundles of the raw data and posting it to Ethereum. And then at any point, if someone says, hey, this centralized server, the sequencer, is cheating, anyone can go and prove that fraud has occurred by just showing that, hey, the data that is posted on-chain for this transaction doesn't map to the hash that you posted as the outcome of that transaction on-chain as well. And as a result of that, the sequencer can be penalized. For optimistic bridges, it's basically a direct extension. I think the model has actually been around longer than optimistic rollups, or not longer, but at least just about the same amount of time. Because I think James Prestwich, who is the creator of this model, has been researching bridges for, well, I think longer than pretty much anyone in the space at this point.
Well, I don't know. I mean, our SK has been trying to do this since what, 2016, right? Atomic swaps. James, really, brought us atomic swaps in a way on Ethereum, where before they were, it was a struggle to make Bitcoin interoperable, right?
I think James was working on Bitcoin interop before anything else.
Yeah, exactly.
As well.
But
yeah.
So just to recap for folks to understand, a fraud proof is sort of like, hey, somebody has said something and everybody constantly gets to check and say, is this a lie? Is this a lie? Is this a lie? Whereas would you say a validity proof is somebody says this is the truth. Somebody says constantly people are looking to see whether or not a lie has occurred as opposed to checking for the truth. So if the lie was made, it can go on and when it's discovered, it's like, oh my God. People can say, I didn't know. So for example, if in the Harmony hack where there was only, I think somebody was telling me their multisig was very small and a number of keys got compromised. When those keys get compromised and everybody starts transacting with that compromised key, nobody knows. You do not know that you're now in a state of untruth. Whereas with the fraud proof, people are continuously checking this proof to make sure and say it is valid. So is that a good way to compare fraud proof versus validity proof in a very simple, at Eli, like I'm 5 way, or is it confusing? Am I still confusing it?
Here's a good analogy that I found that seems to help a lot of people. I don't know what it is about like scalability or research topics and analogies from bars, but for some reason, bar analogies work really well. So imagine you're everyone knows the like state channels bar tab analogy. So this is kind of an extension of that. Imagine you are somebody that is under 21 and you're trying to sneak into a bar. And the bar has one of two mechanisms, right? They have a validity proofs, which is you have a security guard out front that is checking your ID and trying to do their best to make sure that this isn't a fake ID, trying to do their best to make sure that this is, that they are bouncing anybody who is under 21. And then you have a second mechanism, which is a fraud proof. So in the first case, there's a line outside because everybody, there's a lot of overhead to be able to get into the bar. And also you have to make sure that the validity proof, the mechanism that the bouncer is using to check whether or not your ID is valid is actually solid. So, in some places it's more solid than others, which is why in some places like IBC, you have a better mechanism for checking the validity of state than in other places like in a multisig. Both are validity proofs though. And then in the fraud proof model, you actually have something kind of different. You don't have any checks on the bar when you go in at all. Anyone can go in, but if anyone inside realizes that someone else inside is under 21, they can go and report that to the bar owners, and the bar owners will kick out the person that's under 21 and pay a reward to the person that reported them. It's a different model, because now instead of having one person checking at entry and every single person being checked, which of course means you have a higher overhead of checking people and entering into the bar, and also have a single kind of verifier that could have, it could potentially be multiple verifiers, but a single kind of set of verifiers. Instead, you have this unbounded set of verifiers, which is anybody that wants to be in the bar and that is above 21 themselves. Actually, they don't even technically need to be above 21 themselves to report, but anyone that is in the bar, and no overhead up front. But of course, there is overhead later when you prove the fraud. That kind of, I'm hoping that analogy sort of builds an intuition around like, okay, like these are two different ways to actually bounce people from a bar.
Yeah.
One of them involves hiring people and the other involves just rewarding people.
Is it okay to say then that in the fraud proof model, everybody comes into the bar, it's going to take longer for you to get a drink because you need a lot of people to verify that you're really under 21. Whereas in ability to proof, once they come into the bar, I could go straight and get a drink because people say, great, you've been proven valid. Let's go.
Not so. I mean, I think this is probably where the analogy breaks down a little bit, but I don't think that there is. I don't think the lack of upfront verification of a fraud proof necessarily means that there's more congestion in the system. So like in something like Nomad, like all you're doing is adding to a Merkle root, and then that Merkle root is periodically being posted across chains. So that's infinitely scalable, right? Like the scalability bottleneck of that is like how many transactions can the underlying chain do, which is always the scalability bottleneck of anything. So the nice thing is that there's no kind of added verification. Now, somewhat counterintuitively.
Quick question to jump in on you. But
Yeah.
with Nomad, we have to wait for a certain amount of time, right? Before the fraud proof is considered valid. Like we do have to wait a certain number of blocks, right?
Yes.
On Nomad. And wouldn't that be a trade-off? You got to wait. It's not immediate.
Exactly.
And isn't that the trade-off in most fraud proofs?
Yes, and that is 100% is the trade-off. That is like in a fraud proof. Okay, so I see what you meant with the analogy around needing to wait for a drink. So yes, you would absolutely need to kind of wait the full 30 minutes before you know your data on chain is valid. Now there's ways to speed that up too, though. So for example, this is actually what we do in partnership with Nomad. So Connext is a we are a mechanism to build generalized applications and transfer funds across chains. But the way that we do that is that we are actually a layer on top of Nomad. You can consider Nomad like the messaging layer and us the liquidity layer, which is a helpful mental model. But I think the extension of that is that we also like mitigate some of Nomad's trade-offs because we have an off-chain infrastructure network that like can do that. So for example, say you are transferring $100 through Nomad. Normally, this would take you 30 minutes to do because you send a transaction through Nomad that gets posted on the receiving chain. Now you need to wait the full 30-minute timer before you can go and unlock your funds because you don't know yet whether fraud has occurred on chain at least.
Right.
But like an optimistic rollup, off chain, you know if fraud has occurred immediately because an off-chain actor can check the hash that's posted on the sending chain and the hash that's posted on the receiving chain and figure out whether those are the same hash. And it's not very difficult to do. So what you can do as an alternative is something similar to like how you currently get out of optimistic rollups with like Across, Hop, or even Connext, which is you just have somebody front capital and then claim against the transaction that's going over the bridge. Right. So in our case, our Connext routers will then just give a user $100 right out of the gate. And if they wanted to like call a contract, they could do that too. So like say the user wanted to like swap those 100 USDC for $100 worth of ETH on the receiving chain. A Connext node can basically just provide the liquidity for that and execute that transaction and set the user as the output. And then against that, the Connext node operator can claim whatever is going over the bridge after 30 minutes.
Right. So Connext's big value add is the trade-offs that you may experience without Connext, such as waiting for the fraud proof to be verified on Nomad. You no longer have to wait. Connext makes it that you can go as fast as you need to go between chains for either arbitrary message or transmission of value. Is that a good way to?
Exactly.
Yep. Awesome.
So like, it gets you to the point where it's now you're getting about as close as possible to the like idealistic outcome of this is a system that can be deployed anywhere. This is a system that is generalized. This is a system that's trustless, and this is a system that's fast. And it gets you there without making any compromises at all on the trust side.
Got it.
At least significant, reasonable compromise on the trust side.
And in terms of current rollouts for Nomad and Connext, where can we, if Paloma developers want to write code, so for Paloma, our value proposition is, you can write code or essentially try and use Paloma to send messages to any EVM. And of course, send messages to any EVM bridging system or cross-chain communication system. So for Paloma developers who want to send messages across to Nomad using Connext, where would we say that currently Nomad and Connext are deployed that they can start exploring today? Any particular projects you say, hey, here's where we could take a look and continue to be curious?
Yeah. So right now, the implementation, so there's a version of Connext that is live, and that has been live for a year and a half. Right now, we're in the process of doing an upgrade to a new version that is basically built on top of Nomad, and that
Nice.
becomes this shared stack. That upgrade is currently in audit. It should be, we expect that to end in about 2.5 to 3 weeks, so not too far away. And it's also fully available on testnet. So you can, I would say a good place to start would be to check out the Connext docs at docs.connext.network. Well, the way that we think about it is we're a protocol stack, so you end up just calling it to Connext, and then we expose, we pass data down to Nomad as well. So you get the benefits of both in just a single function, which is called xcall. And then lastly, as far as reference examples go, there's a bunch of examples that we've posted about recently. A really great one is Superfluid built a cross-chain money streaming application using Connext and Nomad. So if you look on our blog, which is blog.connext.network, you'll be able to find a Medium post of that, which links to the code base and a general overview of how it works.
Awesome. I think we are super excited about this at Paloma. I think it would be awesome to demonstrate for even our developers writing Paloma CosmOsm contracts that can actually control or send messages through Connext and Nomad on Superfluid. I think that would be super cool for us to explore. And I think we're going to be looking at this and maybe talking more about, essentially building on top of Connext and Nomad for security with the speed as well as the convenience of going fast from chain to chain. This has been awesome. I know we're a little bit over time. Let me just see if there's one quick question from the audience before we go. Anyone here have a quick question or hand raise for Connext Arjun? You want to let me know in 3 seconds, just pop it up. And let's see. Thelema, any questions within the telegrams or otherwise, or we're clear to go?
No, we're clear.
All right. Arjun, this is the first, we want to do another one of these. This 30 minutes was not enough. So we are going to be taking a keen look. Thank you for bringing, the depth of expertise, all the work you've done. Shout out to James Prestwich. James, we love you for all the good work done on atomic swaps and the evolution of atomic swaps, all the way now to, fast fraud proofs on Nomad. I think this will be exciting. For the Paloma community, we're going to Nomad. We want to be able to control contracts and run across Nomad as well. So this is very exciting for Paloma pigeons. Get your beaks ready. We'll be pecking into this. Thank you, Arjun. We will definitely be looking forward to seeing when you guys get the audit complete so that, again, we can continue to explore. Thank you so much. Thank you, everybody, for joining. This has been an awesome, awesome chat. Look forward to seeing Connext in the future. Thanks, Arjun.
Amazing.
Thanks
Thanks
guys.
so much for having me.